Hello, this is Jay Bowden, software manager here at Titan. Looking to do a demonstration video on the service and maintenance calibration features of our hydraulic test engine. In a previous video I had shown how the operators will use our software to run tests, collect results and do all of that, and then in this one I'll show some of the maintenance features. We did not go into great detail in the menus, and the ones I would like to cover in this video are some of the ones under the utilities menu here. The utilities menu, we have available a fault viewer, a system events viewer, specification editors, calibration screens, both general 2-point and multi-point calibration, manual control screen, service mode, graph for charting data to view and save, and then looking at some of the critical checks and background tasks. Some of these features are not fully implemented because this is a demo, and I did not have enough time to put it all together, but it should give you a pretty good feel for what any kind of maintenance supervisors or maintenance technicians might have available to them to troubleshoot the stand or even the unit under test. A lot of these features are only allowed if properly logged in. And so they would be grayed out if they weren't logged in with the proper authority. So I'm going to start here real quick, and actually I am going to run a test here and abort. Yes, run from current location. Okay, so I faulted a test on purpose here so you can see that I have a fault along the bottom. I can acknowledge them here if I was the operator, but I wanted to show here that our fault viewer will keep track of current and active faults while the software is running. So you can see text descriptions, the error numbers, times, dates. You can also acknowledge them from here if you wish. Continue. Cancel. Not a number. No. Abort automatic testing. And there we go. Okay, so I'm back out of test mode. So that was an example of the fault viewer. System events are mostly for the programmer to debug any kind of system issues you might be having. If you report that something's slowing down or there's error happening within the software at some point, we can go through here and kind of check our log of what functions we're calling and when they're happening, what times. It's a debugging tool that we use, but we can also write these to files. And so later, if you realize you're having an issue in some location, you can just send us the CSV file. That would give us all this information too. Close that one down. Utilities. Specifications, I'm going to cover the specs and how to edit and create tests in another video after this one. So I will not get into great detail here. I'm going to continue on here to our calibration. Calibration menu, we have a general 2-point calibration. So for any channels that we have defined, analog type channels that we have defined in the system, we give a simplistic 2-point calibration here, where, for example, our rod head pressure, you can see our live readings here, what our current offset and scaling is, but then we can apply a point here of however many bar or whatever units you're in, and we can record that. So if you put a dead weight on here, you applied a few bar onto it, so let's just say 20, you could record that point. And then you could apply another setting, record that point, and we'll automatically calculate the offset scaling and show you what your new live values would be, along with saving it to our calibration file. Kind of have some step 1, step 2, step 4, 3, 4 instructions here to guide you through that. We also have the ability to have calibrations with multi-points, which is basically a lookup table of points. So you'd have your current value, your current voltage, and the new ones as we record them. I do not, for the demo, I don't have any channels mapped out as a multi-point cal. If you did, they would show up in this drop-down list. You could pick them, and then you could have 10, 20, 30 points, and if you want for nonlinear type transducers to calibrate those with a table lookup. Inserting, copying, deleting rows out of this table, but you can do a lot of this manually here. As you go to, you could also use a feedback channel. So let's say you had a analog input that you wanted to calibrate this channel that you picked here against. You can always get to this point. When you enter the point, you can actually do a record here, which will record the live voltage here. So you can do a one-to-one recording of the live value as you go. calibrate an output, let's say, to match your transducer. Again, once you're done, once you've added or made changes, you can do the save here, and that'll save your data to our cal file. Manual control screen. In this case, we don't have a full manual control screen. This would be if you had some lower level circuit controls. We do give you the ability to use our charting tool here to record, add lines to it, rod at pressure. You can start and stop recording and use this chart however you'd like. You can add any kind of channels from our service program. This will also let you print, record data to image file like JPEG, bitmap, and you could also push it to a CSV file of raw text data to be pulled into Excel or anything else done with. Once right now I have 0 data being simulated, so you're not seeing much coming in here. If I was to simulate head pressure or rod pressure or anything like that, you'd be able to see the data come up here live, and you can start and stop it right here. Add, remove channels from our service program. Change your axes values, Y1, Y2, to rescale your axes. Change the update and recording intervals. Service mode covers our low-level I/O mapping and integration. I will come back to this in a little bit because that'll be a lot of detail covered in that. Another graph screen here. Now this brings up the basic graph again. In case it wasn't included in the hardware macros, just another way to get to it. Critical checks and background tasks. So sometimes you'll have an interface here that'll have buttons, controls on it for low level, maybe checks on watchdogs or master control relays, filters possibly, and those could show up here. In the demo I put together, I don't have anything put here because we started to build it as part of the screen on the main interface. Usually they'll either reside here so that the operators can actually see it and use it, make use of it. If not, we would build it into that screen I showed you here. Now, the service mode is used for low-level troubleshooting and testing of the low-level discrete I/O channels. So you can see this window just floats in the background once it brought up. Again, this is locked out unless they have the proper user rights. But you can see I have digital outputs. I'll have some digital inputs, not on this one, but you can see where I'm extending, retracting, along with any kind of mappings or properties that would go with those channels. So you can add new channels, you can create new channels, all tied to any of the data acquisition that's built into the system. Here we just got digital outputs, I got some spares, we can create variables. Here's an analog output for our output pressure control. So at any time I can come in here and set it to whatever I want. You'd see now this would be physically writing this value out to the channel. It's scaled a little bit differently, so it doesn't come out to be quite exactly the number I entered in. Analog inputs, so these values here will actually update live as the data acquisition's updating the values. You're allowed to save or reload any of your changes you made, so you can reload from file if you wish, or save. All these settings get loaded automatically when the software loads, so normally you wouldn't have to do any of that. I/O, I can create new channels, I can create a copy, I can delete them. I can use my calibration screens. Again, these just bring up the same screens that we had before, so if I'm already on a channel, my calibration screen will auto select that one and bring it up. I also have available the multi-point calibration. I can rearrange my channels in my boxes. I have some speed test stuff here for testing software, and then what kind of display characters are in there for different types of formatting for different messages we use for some serial strings. Again, in this screen we make available the graphing tool, so if you actually wanted to chart any of these values on here, you could add them in here. For example, start, stop, and you can record, see it live. Maybe you want to turn on the extend from here and watch it live as it's extending. You can do all that right here. Now I don't have any hardware hooked up at the time, so you don't see anything changing. As I'm going through though, if I'm running this on a desktop, I can simulate all this, but you can see by double clicking, turning it on off. or just typing in values here when I'm. So a lot of the simulation can be done on a desktop. Even if you're running tests and everything, if your test is running in the foreground, you could come over here and type in values to have them fake out the tests, actually record and calculate data, pass, fail, all those things. And you'd also be able to switch back and forth while the test is running to see live status. So as things are going, if we're extracting cylinder, you can come back here, see if this digital output's actually energized to see live what is going on with the hardware. The tool graph again, we make use of that a lot for seeing everything going on, and then help. So we can do some about where you get some version numbers, a few other things in there. So, all right, that is the end of the screens and the features built into our test software for maintenance, calibration, and service of the stand. I will be doing another video to cover some of the specifications and software editing.